Now we will derive the reduction formula for the integral of cosine to the power of b of x dx, and we're going to follow the exact same procedure that we did for the reduction formula for sine, only now we're going to do it for cosine. So we're going to realize that cosine to the power of b of x is equal to cosine to the power of b minus 1 of x times cosine of x. And now that we've written this integral as the integral of a product, we can easily apply our integration by parts. We allow u to equal cosine to the power of b minus 1 of x. du is then equal to, well, we bring the exponent out front, b minus 1 cosine to the b minus 2 of x times the derivative of cosine, which is negative sine of x, dx. Now we're going to allow our dv to equal cosine of x dx. And if we integrate both sides, then we get v is equal to, well, the integral of cosine of x is sine of x. And now we can rewrite our original integral. So cosine to the power of b of x dx is equal to u times v, which is sine of x cosine to the b minus 1 of x, minus the integral of v du, which is sine of x, times du here is b minus 1 cosine to the b minus 2 of x times minus sine of x dx. Now I will focus on the integral on the right hand side to simplify that. The negatives cancel out, we get an integral. And once again I will write the b minus 1 on the outside here to make it easier. Integral of sine squared of x cosine to the b minus 2 of x dx. Now we can rewrite our sine squared of x to be 1 minus cosine squared of x times cosine to the b minus 2 of x dx, and this is equal to b minus 1, and we're going to separate the integrals here, cosine to the b minus 2 of x dx, and then don't forget the negative, so it'll be a minus b minus 1 times the integral. Well, when we multiply these two together, the 2's will cancel out, and we'll get a cosine to b of x dx. Just like in the last example, we will add this over, and then we will solve for the integral of cosine to the b of x dx. Now we get the integral of cosine to the b of x dx plus b minus 1 times the integral cosine to the b of x dx, and this is going to equal, well, we can't forget our sine and our cosine to the b minus 1 of x, so that'll equal sine of x cosine to the b minus 1 of x, and this will be plus whatever we have left on the right hand side here, b minus 1 cosine to the b minus 2 of x dx, and that is our reduced integral. Now solving, we will get a 1, and this will be plus b minus 1 times the integral of cosine to the b of x dx, and I won't worry about writing the right hand side here just yet. We will see that the positive one and the negative one cancel out, and we'll be left with a b, and if we divide by b on both sides, then the result that we will be left with is the integral of cosine to the b of x dx is equal to 1 over b sine of x times cosine to the b minus 1 of x plus b minus 1 over b times the integral of cosine to the b minus 2 of x dx. And this is our reduction formula for cosine to the b of x dx. And if you look, it's very similar in this case that we had over here to our reduction formula of sine of x. There's just some differences in negatives and constants and whatnot. But the idea is the same for both, and we're going to start off with these powers of sines and cosines that are too high for us to directly compute, and through repeated iterations of this reduction formula, we will simplify them into integrals of sine and cosine of the first power, which we know how to directly compute. And we will look at some more examples in the next one. And until then, I hope you enjoyed. I hope you understood. If you have a question, please leave a comment below. And until the next one.